Understanding terrain elevation is crucial for surveying, construction, and land development. Contour lines provide a clear visual representation of elevation changes, making it easier to analyze slopes, drainage patterns, and terrain features. In this tutorial, we'll walk through the process of generating contours in PixElement, from creating a triangulated irregular network, or TIN, to exporting contour data for further analysis. Before generating contours, you will need to create a TIN. You can do so by creating a grid and then generating a TIN from that area. You are also able to generate a TIN via the Generate TIN tool. Within the TIN tool menu, you can choose to generate a TIN from the entire dataset or a specific selection of features that you select. Once the selection is made, click Generate Automatic Outline, then Triangulate Selection to create the TIN. A TIN is a type of spatial data structure used to represent continuous surfaces through interconnected triangles. Unlike regular grids, TINs can handle irregularly spaced elevation points, making them effective for detailed terrain representation. Once the TIN is created, navigate to the Contours submenu to generate the contours. Here, you can adjust the contour interval to customize how frequently elevation lines appear, set the Z maximum and minimum elevation to generate your contour lines at. To get a better understanding of the specific elevations of your dataset, you can create a polyline and view the elevation profile in the Profile Viewer tool to set your parameters. Once processed, your contour lines will appear to the specifications you set. Next, you can set the contour size minimum line, or min size, which defines the minimum length of individual contour lines to include. Increasing this value filters out small, short contours like minor surface bumps, helping to reduce visual clutter in your final output. Select the Contour Smoothing Factor, or smoothing, which sets the smoothing level of the contour lines. This example shows the topographic lines with no smoothing, low smoothing, medium smoothing, and high smoothing. Next, you can toggle Trim Edges, which intelligently trims away components of contour lines that make contact with the border of the TIN, and toggle Index Lines, which are displayed in bold and are annotated with an elevation measurement in the scene, as well as set the frequency of the contour index measurements for every nth line. The generated contour lines provide a precise elevation map, which is essential for site planning, land development, and hydrological analysis. Depending on the surface of your map, the contour lines may be difficult to see. To see the contours more clearly, you can toggle off the surface model or dense point cloud, respectively. After generating contours, the data can be exported in DXF or SHP file formats. These formats are widely compatible with CAD and GIS platforms, allowing seamless integration into various workflows for further analysis, design, and planning. By utilizing the contour generation tool, you can efficiently visualize and analyze terrain variations, aiding in more informed decision-making for your projects.